Hello mathematicians, what we're going to do on this lovely day is that we are going to find the real roots of this lovely quartic function, and we're going to do so by graphing. Notice number one that we're going to find the real roots, not complex solutions, just the real roots. We're going to do so by graphing. Now, one method and one standard practice in all of algebra is that if we had a system of equations, and in this case a system of linear equations, we know that the solution to the two equations that satisfies both equations, in other words, the solution to the system, is where the intersection occurs, so right here. Well, it turns out that we can do exactly the same thing with any algebra problem. Is if I turn the left side into a function, and I turn the right side into a function, then what happens is that whatever happens, all we're looking for are the intersection points. So just to give you a heads up, if you're using a TI-84, which we're going to do momentarily, it's going to take 322 years. However, if you use Desmos, it can be done in a matter of seconds, and all you have to do is tap the intersection points, and it'll actually find them for you. And of course, pinching and zooming, you can get in and out and see things very easily. But just because we want to be tedious and torturous, we're going to look at how to solve this using a TI. So let's scoot over to your TI calculator, and we're going to go to the y equals button. So I already have my two functions set up, 2x to the fourth and 9x squared minus 4. So when you hit the graph button, ka-chow, you get this. Now, unfortunately, this is a lot of ugliness. We don't know where stuff intersects. We don't know how high. But one thing we do know is that this is wasted space way over here. This is wasted space, and there's a good chance I'm going to need to see above. So I'm going to go to my window, boom, and I'm going to make some changes. To the left and right, notice that I didn't really need too much. So I'm going to say -3, going that way. I might change it later. Then I'm going to go to +3 on the high. Count by ones, twos, it doesn't really matter. Next, I'm going to go to the minimum. Notice I do not need to go under very, very much. So looks like I'm going to go ahead and put -5 just for the heck of it. And I'm going to put y max. Well, not 10. I clearly need to go higher. So I'm just going to temporarily put 20 there to see how I do. I'm going to count by fives just to save some space. So, here's my x to the fourth. And then here's my quadratic. Oh, nice. So I see here that there's some intersection that probably occurs right here. And up there it looks like slightly higher. So what do I need to do? Adjust my window. So how do I do that? I'm going to go to my max and adjust that. I actually don't know how much, but maybe I'm going to double it. Okay? See what happens. Go back to my graph. Now, things are fit pretty much in the window. And I do see that some sort of intersection occurs here, 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 and here. Now, that's important information because one thing to consider is whenever you have a quartic function, you have upwards of 4 zeros that will occur. Now, we could have the multiplicity. So, for example, x minus 4 to the fourth power equals y. This number right here, the +4 as a 0, shows up 4 times. It has a multiplicity of 4. So you might get that, but looks like based on our graph that we are going to come up with 4. One intersection here, here, and then one on either side here. So how do we do that with our calculator? So I need to go to my calc button right here. So I go second in calc, and I'm going to find not my zeros like historically we've done. I'm going to press 5 for intersect. So up here it tells you which curve you're currently on, and it just asks you which curve you want to be on, and which two curves you want to find the intersection of. So I want to find the intersection of that curve and this one. This is only beneficial to select those is if you have 3 or 4 functions up, but since we only have 2 functions, we're going to select them both by default. Now, it asks us to find make a guess. So I'm already at this one right here. So I'm going to guess. And it doesn't actually matter how close you get too much. The calculator will just take longer. So I hit enter, boom, and the intersection, one of my solutions is -0.707. So I can actually come over to here and set that up, -0.707. And there we go. So let me come back and find another one. So I'll repeat this one more time and then finish up the rest fast. So I go second calc. I'm going to hit 5 for the intersection. Try that again. Second calc. Second calc. And hit 5 for the intersection. Okay, now I'm going, my first curve is already done. My second curve, I'm going to hit enter again. And my guess, this time I'm going to go up higher because I wanted to find out what this one is. And again, we're only looking for the x values here. So I'm hitting enter. When I get to it, oh, look, a -2. So I'm going to come over to here. And I see that my x is approximately -2 as well. So again, we're only looking for the x values because, look, in the original function, there is no y value. Or it's not even a function. It's an equation. So there is no y. We're just temporarily setting them up as y's so we can find the intersections. Now, when you continue to do that, it turns out that you end up getting plus or minus and plus or minus. And again, using Desmos is much faster because you can just tap and find your solutions. Only the x values is what we want. So I'll pause there, and we're going to look at an alternate method on a separate video.